evening, good afternoon. Take my greetings according to your timing. So, I'm back with the next lecture of stereochemistry, where I will be continuing with the topic of optical isomerism that I have taught on my last lecture. So, I hope I have completed everything about optical isomerism except just two terminologies. So, I would just recall you those two terminologies and then move on to my next topic about the configuration. So, let's see. The first terminology that I want to say is that racemic mixture. I have already told you about racemic mixture. So let me explain it in a more brief and detailed way. Not going much into it, deeper into it, because it's not that much important, but still I'm writing the definition for you all. Okay, what is this? So racemic mixture is what? An equimolar mixture of D and L form is known as racemic mixture. So I'm writing over here. An equimolar mixture of D and L form is known as racemic mixture. Racemic mixture is optically inactive due to external compensation, right? What is this? I'm letting you know what is this. Mixture is basically is optically wait just a second, is optically inactive due to external compensation. What is this? I'm showing you. I would not write any more example over here. Instead, I would choose to show you over here. Let me take one thing. Okay, see here. Here I said that 3 and 4 is basically inactive. See, 1 and 2 is diastereomer, but enantiomer is 1 and 2, 3 and 4. 3 and 4 is basically inactive. You know why? See, from here you can see that I'm writing with this pen. Okay. Sorry, I think some error is there. Writing. No, nothing. Just a second. Might be some issue with it. Okay, here comes. So in this compound you can see that here I have C. Fine, CH3, and if I want to rotate it from here, this is our least order priority. I will show you what is least order priority and all, but before that I'm just moving it from here. So one thing you will see that one will rotate from here to come to here, but another one will rotate from here to come to here. So you can see that the two rotations cancel each other. This is the equimolar proportion of R and S present in a single compound, cancelling each other and making it a racemic compound. Fine. So this is the complete form of racemic mixture. Now coming to the next point, mesoform. What is this mesoform? Okay, mesoform. Mesoform, right? Okay. A compound having two or more asymmetric carbon atoms which superimpose on its mirror image and hence optically inactive is known as mesocompound. Means a compound having two or more asymmetric carbon atoms which superimposes on its mirror image and hence optically inactive is known as meso compound. Fine. So, let me write this for you up over here. See, a compound having two or more asymmetric carbon which superimposes on its mirror image and hence optically inactive is known as meso compound. Means you have an asymmetric. Let me give an example. I hope you know what is the meaning of asymmetric carbon, right? That which have different formulas over there. I can't found any meso compound over here. Once I get, I will write it. Okay, fine. Okay. These all are active actually. Okay, I will give you an example. Let's suppose this is a compound C. Okay, and this is asymmetric in nature, which you have C. Here I have A, I have B, I have C, I have D. Fine. So two or more asymmetric carbons. So this is one asymmetric carbon. Let's say in this compound this B consists of another carbon. Okay, and it has the similar configuration type. Okay, it has similar A B C, sorry, A D C. Okay, fine. So you can see that this and this is actually asymmetric in nature. Okay, but in case of mirror imaging, and they actually superimpose on each other. See, I will create this mirror image, you see. Okay, and you can see that this will superimpose on this. That means this compound is actually meso compound. They will superimpose on each other when I will do the mirror imaging. So this is actually optically inactive in nature. So mark this point. I am highlighting again that meso compounds are basically what you have to remember. I am marking that only. Optically inactive in nature. Fine. And racemic mixture is also optically inactive due to external compensation. Okay, here this is due to external compensation, I'm marking, and this is due to what? Due to superimposing of its mirror image. Fine, I have marked the important terminologies that you have to remember. So here I actually conclude the optical isomerism. Now moving to my next topic, that is our RS nomenclature. So come back to the next topic of RS nomenclature. Fine. Okay, just give me some time. I will put a beautiful heading for you all. Okay, here you see RS nomenclature. Okay, let's select this. Once I start with this RS nomenclature, let's talk about the configurations and everything. So you have to remember some points and I'm writing it for you. Okay, so configuration point. First point is configuration. When I talk about configuration, I hope in your plus 2, as we are studying the engineering chemistry, you have already learned about the configurations and all. Let me give you a brief recap of everything. And yeah, here from here actually the chapter has begun. Okay, optical isomerism is also important. Don't just take it in a easy way, but from here you need to get a better understanding of each and everything what I will write over here. So please, I request, if you have any doubt, please write it in the comment box so that I can understand that you are having queries over there. So come to here. So the configuration says that, what is this? This is our vertical line, this is our horizontal line, right? So any group, this is, let's say this is A, this is B, this is C, and this is D. Okay, so if any group is there, and then we are doing like this way, this is our D, this is actually, let's say this is our carbon, right? This is our carbon. Okay, let me draw this carbon with yellow. Okay, this is our carbon, and we are having over here, okay, this is carbon. Okay, whatever it is present in the horizontal line, this line, this is called as wedge. Okay, this wedge is always out of the plane. Okay, and now if I will go for what is out of the plane and all, I'm just going through it, just give me some time. Okay, this is our wedge. Okay, here I have written B. Okay, fine. Then come to here. This vertical line actually represents below the plane. Okay, it's our A, this is our C. Okay, so this actually represents what? Let me say you everything. This horizontal line is wedge. Is wedge. Okay, this vertical line is actually dash in this case. Okay, this means above the plane, and this means below the plane. Okay, done. So you have to get some targets, and what are those targets, and how will you determine those targets and everything, and how will you put each and every group. I have just taken an example of ABCD, but there is not ABCD, there are some groups and some compounds over there. So how are you going to put each and everything? So we always have to keep this note in mind. I'm writing it in a note form so that you will again recognize it. Okay, this is important note under configuration. So I request to write notes in different colors so that you can always remember what is the note point. So we have to always keep in that mind that lowest priority group should always come below the plane. Wait a second, I think I have done the mistake in spelling of wedge. Just check it once. Okay, with spelling I think I have done some mistake. So lowest priority group should always come below the plane. This is our target, or you can say that this is our main note. And if not, see, sometimes we have to draw projections, sometimes we will be given the projections. So when you will draw it like this way, giving the lowest priority thing in means like in below the plane order. But in case of lowest priority group is present, priority group PG I am writing, group is present present in horizontal position, suppose. Okay. Then the configuration will reverse. This reversed. Okay. Or you can say lowest priority group and always below the plane. And if it is in vertical position, configuration is same. I'm writing short form, configuration is same. Okay. So again, I'm revising this topic for you so that you can have a clear overview of it, because once you miss this, I won't be able to make you understand what's going on next to next. So lowest priority group, and how you will assign this lowest priority group, we'll be discussing just after this topic. Okay, so this lowest priority group should always come below the plane. What am I writing? Come below the plane. Fine, below the plane. If it is in vertical, that means it is in vertical position. Okay, below the plane, I have shown you over here that this is below the plane. Where it is vertical, it is below the plane. So you can see here clearly that it is below the plane, and the configuration remains the same. That if it is R configuration, it is S configuration, it will definitely remain the same as it is. But if it the lowest priority group present in the horizontal position, means in here in this case, just take this, I have taken this in. See, A is the highest priority and D is the lowest priority. Here you see this, the lowest priority group comes at the horizon. What should I supposed to do? That means it is not below the plane, it is above the plane. So in this case, if the configuration is, see, what is this configuration? If I will come from here, this is our, this is what, this is our clockwise, that means R. So R, if it is R, then it will convert into S. Okay, the actual configuration is S configuration, fine. But in this case, it is in horizon, that's why. But if it is in vertical position, it would not have any kind of change. Okay, I think I'm clear with my first topic, that is configuration part. So moving to the next topic. Okay, let me give some more examples to you. Now, how can we determine, I'm writing it for you. Okay, how can we determine this lowest priority group? This is the biggest question. Or you can say that how we will consider the whole group order. Okay, for that comes our CIP rule. Why am I writing in a question way? Because you need to sometime remember why are we studying. So that's why I'm writing in a question way. But this is the next topic actually, and very, very important one, I guess. CIP. Okay, what is CIP rule? We determine it through CIP rule. It through CIP rule. Okay, what is this CIP rule? Come over here. So let's discuss this CIP rule. Okay, fine. So CIP full form stands for CAN, CHAN, CAN, in gold Prelog nomenclature. So our CAN, CAHN, I guess. And in gold, Trilog nomenclature. Okay. So here, what are we going to know from here? See, first when I am talking about R configuration and S configuration, I want to make one thing clear. What is R and what is S? Okay. I will go next, but just simple one thing. When I'm writing R and S, I'm just going to show you one thing. See, how we write actually R. This is our R, right? And this is R. Fine. So you can see the arrow over here. How I have drawn the arrow. It is in clockwise direction, right? And this is our R. This is clockwise. Okay. And once I explain you from here what is S, see, this is our S. And how we are writing this S? We are writing it in anti-clockwise. That means the arrow comes over here. That means it is anti-clock form. Clockwise. Why I'm writing it over here? I just want to give a brief description, that's why. Okay. So next point. RS in nomenclature. So first thing you will keep in mind, what is RS? R stands for. R is actually derived from a Latin word. R and S both are derived from a Latin word. Let me write it. S derived from Latin word. Where R stands for rectus. Okay, rectus means what? That means right. Okay, and L stands for, sorry, S stands for what? Why am I writing S? I don't know. Left is coming on my mind, that's why. That means sinister. What is this? SINISTER. Okay, and that means left. Fine. In optical, we have studied about dextro and levo, and here in RS nomenclature, we are learning about R and S. R stands for what? Rectus, and S stands for what? Sinister. Fine. So, moving to the next part. What actually this all means, and for your conventional thing, I am writing here R is actually clockwise rotation. Okay, this clockwise rotation, and this is anti-clockwise rotation. Fine. Okay, so how will you check the rotation? So this is our next point, checking of the rotation. Yes, so next point, checking of rotation. So you will always check the rotation in the order of higher priority level to lower priority level. Means always check from higher priority to lower priority level. Sorry. To lower priority level. Okay, fine. So what does actually I mean? I means that the group that will be labeled as 1, you will move from here, and the rotation will start from 1, and then you will slowly move to 4, covering all the other things. Okay, so always remember one thing. Always keep this point in mind, that lowest priority group should always below the plane. This is very important point. I'm highlighting it for you. Okay, that lowest priority group should always be below the plane. Okay, this is very important point. I would give it a 7-star thing. Fine, that you always need to remember this point. So otherwise the configurations will get reversed. I'm writing it under the CIP rule as well. In third point, I'm writing that lowest priority group always comes below the plane. That means always comes below the plane. That means in vertical place, in vertical position. Okay. Else configuration get reversed. It's reversed. Fine. Okay, these are the points. Okay. So here reverse means if it is R, then it would convert into S, and if it is S, it will be R. Okay, so I have completed 3 points over here. So coming to the next point is, how will you determine the steps? So steps to determine the lowest priority group is like this way. First, you will assign steps to determine the priority order. Okay. Steps to determine the priority order. First step is atom with higher priority higher atomic number will have higher priority. Has priority. Let me give you examples to make you understand what does I mean to say about this step. Okay, I want you to write all the steps one by one, but let me give you example, else you won't understand. Okay, so see here I am taking an example. This is our Cl. This is, let's take some different color. Yellow. Okay, this is our chlorine. Okay, this is our iodine. This is our SO3H, and this is our hydrogen. Fine, let's write the atomic numbers of it. So I think let's start from hydrogen. Hydrogen atomic number is 1. So after this comes the chlorine with atomic number 17, and then comes iodine, the atomic number is 35, and then comes S with atomic number 16. Okay, so here you can see that this is the atomic number of this. So how will you recognize each and everything? So you can see the least one is 4, so means like 1, so you atomic number 1 is hydrogen, so you will give this as 4. This is the priority. Our least priority is coming at the horizontal position. Okay, here I will show you. Okay, and then highest one is coming over here, iodine. Okay, iodine, I'm giving it 1. Okay, then second order is coming from here, this one, 2, and here it is 3. Fine, you can understand how I have just given the priority. C7 35. Okay, this is the thing. First iodine will come because it is 35. Okay, 35 is greatest. Then it's chlorine with 17. Okay, then it is obviously SO3H because S is having 16. Then comes my hydrogen with 1 atomic number. So this is the whole priority order. Fine. And once you set the priority order, and then you will have to do what? Rotation. Let me take this one. Okay, how will you show this rotation? From 1 you will go to the next one. So how will you do it? You have to cover each and everything. Fine. So once you start covering the thing, that you can see this is the lowest priority order present in the horizon position. So at least you need to understand 2-3 facts over here. The answer you will have, see, I will move from here, and then I will come to here as SO3H. Okay, why I will do this kind of rotation? Because I have to totally calculate each and every position and come to a certain fixed value, because here I am having 4 and here it is 3. Why shouldn't I be moving from here to here? This is actually not possible. I have to cover each and every position, and you have to always remember that covering each and every position will take you some values. Okay, and here I will determine like this way. See, I will have to come over here and I will just rotate it from here. This is my R configuration. Okay, this is our R configuration. Okay, but as it is having the least priority order in the horizon place, it will be actually S configuration. Okay, so here you can see this is the way how you move to 1 to 3 position. Okay, always remember that as you have to go from covering first higher priority group to the lowest higher priority group, you will move like this way, 1 to 3. I am writing the rotation over here. You will move from this way. This is our R clockwise rotation, but as it is having the least value at fourth position, it will come as S as the final answer. S is the our final answer. Okay, I hope you understand what is happening. So, moving to the next step. First, this is the way how you determine. Let's say what has happened. After this, you find some isotope form. Okay, isotope form. If isotope form is present, are in isotope form, I hope you understand what is isotope. Like hydrogen has having isotope of deuterium and tritium. So these are the isotopes. Okay, if you have isotope form, then what will you do? Isotope with highest mass number, or you can say that atomic mass has the highest priority. Okay, if I have to choose between hydrogen or deuterium, I will go for deuterium as the highest order group. Okay, so I'm writing it for you. Isotopes, isotope with higher mass number, holds higher priority. Okay, fine. Come, so let me show you how does it holds. Let me take another example, once again deuterium type of example. So here I am again doing this. Okay, fine. Okay, here I am taking hydrogen at vertical position, but bromine over here and deuterium over here, and H3C, okay, over here. Okay, so the thing is very clear about 2-3 points. First, what is this bromine? You know, bromine is the highest one over here. Bromine. Then I will come from where? Then I am having carbon. Okay, carbon. Then I am having what? Then I'm having deuterium, third position over here, and finally the hydrogen over here, because you always remember the isotope form of it, of hydrogen. Basically this is something that are means like when questions are going to be more typical, they would do it like this with this 3T1, and you know, this is tritium, this is our deuterium, and here comes my hydrogen. Basically this is the order. So this is the way how you will do. So how I will now rotation, coming to the rotation point. So now coming to the rotation from here, from here I have to move to the third position. How will I do it? I will go from here and come over here and then here by covering the whole thing. So you can see this is an anti-clockwise rotation. So as this is anti-clockwise rotation, finally we can say that this is S configuration, and here the least priority is present in the vertical position. I don't have any problem with it. Okay, so again and again I am showing the two basic things to you, that reverse will happen only when this lowest priority group is present in horizontal position, or you can say below the plane, else there will be no problem. Fine, this is what the second step is done. So coming to the third step, we had dealt with two things. First the atomic number, next with the isotope. And if the third thing comes when we are talking about that we have same, means like here I have carbon, here I will also have carbon, then how am I going to determine who is going to have more value? See, here we are having, say this case, here we are having SO3H, but here this is chlorine, 17 is more than 16. So it is very easy for us that chlorine will have highest priority, and obviously sulfur will have less priority, and it is 16. Fine, but if I am having SO3H here and SO4H here, whom should I give more priority? Obviously we will find it in our next step. See, the third step. The third step. The third step says if two or more atoms attached with the chiral carbon are same, priority is decided by applying priority rule to the next atom in groups and so on. Fine. So this has happened, and what do I mean to say? See, I am having chlorine over here, hydrogen over here, and here I am having CH2Cl, and here I am having CH. Here this is our CH3. Fine. Okay. See, I'm taking different plane for it. So this is clear that chlorine is going to have the highest priority and hydrogen is going to have the least priority. Done. Now who is going to be 2 and who is going to be 3? Here what does this means actually? This carbon means here it is like in this form CCl. This is our hydrogen and this is our hydrogen. That means actually this carbon atom attached with this adjacent carbon atom is having chlorine as its in its one hand. Okay, but in this, when I'm talking about this carbon, it is basically what this carbon is having in 1 2 3 4. Okay, fine. If I'm talking about this carbon, this is what this is having in here. I'm having what this, I'm having hydrogen, and here I'm having again a carbon CH3. Here I'm having in CH3. Here see, you can find that this chlorine is having a atomic number of 17, but this carbon attached with this carbon remains the same. Okay, the value is going to be same for this all. Okay, so we will actually give this more priority and it would be marked as 2 and it would be marked as 3. I hope I have made it clear to you how am I marking. And once I will go from here and then I will just do the rotation. What would be the rotation in this form? This is going to be R form. Why? This is our clockwise rotation. Fine, this is our clockwise rotation. This is our R form. And as it is present in vertical position, no issues, then the final answer is obviously going to be R configuration. Fine. If you have any doubt, put it in the comment box. I will surely going to resolve it. So the third point is done. Now the fourth point. Fourth point is what? How to deal with the double bonds and triple bonds. The same way how you deal with the last thing. Double bonds and triple bonds. Okay, so here I am doing what? I am writing it for you. If I am having a carbon with double bond O, okay, it, how do you represent it when I am going to mark it in the form of R and S? You will do what? This is a carbon. We actually do what? This is a carbon. When we actually try to break it, we consider it there is one oxygen. Fine, and another oxygen will come over here, this carbon. But to actually moderate it, we will just add a fake carbon to it so that it will actually have a normalized form. So you can see this is the actual form. And then when I talk about the C double bond C, this is a very common form, right? It becomes, this is our C double bond C, means I have to add one C over here. The next bond is over here. To just means like resemble this bond, I will add another carbon over here, extra carbon. Okay, and coming to triple bond, C triple bond N. This is a very another common form. Okay, here this is our carbon and this is our nitrogen. First we will draw this. Then for one single bond, I will attach one nitrogen to it. As I attached one nitrogen to it, I will have to add one carbon to it as well. I have added this one carbon to it. Okay, but I have another one bond left to break. So here I will add another nitrogen to it. And once I add another nitrogen to it, I will have to add another carbon to it as well. So these are the two extra carbons that I am adding over here. So this is the actual from how you deal with double bonds and triple bonds. And once you are done with this, then you can actually recognize the atomic factor, atomic number of it. And you can see how adjacent and carbons will determine it. Here you will see this is oxygen, this is oxygen. Two oxygens are present over here. That means it would have higher priority than anything that would have only one oxygen present to it, obviously. Okay, if I will give you just an example to remember, means like I'm giving you an instance such as CHO. Okay, this is one bond and I'm having COOH. Whom should you give higher priority? Okay, you can do it from that position, that acid is having higher priority, I will give it this higher priority and this is lower priority, but actually it is determined like this way. Fine. Okay, so let's move to last thing of the day. So if there will be a condition of cis and trans, I will make you understand what is cis and what is trans, but the actually the short of time, or I don't think that you will continue this lecture after this so long period, so I'm overing it over here. If I have to choose between cis and trans, priority to cis and trans, always remember, always cis form will get higher priority. Okay, for example, this is a carbon, this is a carbon, I'm having chlorine over here and hydrogen over here. Okay, and then I'm having this, let's say I will draw a trans over here. I'm having a carbon, then I'm having double bond, then here I'm having C2H5, and here I have normal hydrogen and hydrogen. Okay, and another thing we are having like this way, this is another carbon, adjacent to it I would draw like this way. Okay, this is the form, and here I have C2H5, and here I am having hydrogen and hydrogen. For I will make you understand what is cis and trans, but before that just remember this is the cis form and this is the trans form. And how am I doing it? I'm writing it, I'm just determining it with different color. Okay, see this one thing, this is the trans form. Okay, when you can see the highest priority group in diagonal position, this is the trans form, and this is our cis form. I'll show you that it cancels the rotation and everything. I'll show you. And this is the cis form. So in cis form it will have the highest priority. So how you will prioritize the group? The first priority obviously go to the chlorine, the next priority will go to C2H5, and third priority is this, and the fourth one is this, and you will move to third position like this way, 1 2 3. Okay, so finally you were having what? Anti-clockwise rotation, that means S configuration. Okay, so I think I have made you clear all the topics of this portion, and I don't think that you have much doubt over here. I will make you practice some more few questions about this topic once I come to a closure, but I expect you to be more regular with the classes and make the notes, and hopefully you will enjoy the next classes as well. So I request you to complete the notes, and then we will be meeting you on the next lecture. So that's all for today. Bye bye.